Hi there, this is Dr. Zain Hakim with a walkthrough of the RxBayes medical app. This walkthrough is intended for people who already understand Bayes' theorem and are just looking for a rundown of where things are located and how to use the app. If you want an explanation of Bayes' theorem or an understanding of the mathematics of Bayes' theorem or an explanation of how Bayes' theorem is related to clinical practice, that can be found elsewhere on this site. The key meat of the app is actually related to these sliders. This is the pretest probability, sensitivity, and specificity. And by changing those, the app uses Bayes' theorem in the background to calculate the positive predictive value and the negative predictive value based on the values that you've input. Many sites have Bayes' theorem calculators that you have to individually enter data for. The whole point of this app is you can, in real time, see how changes in pretest probability or changes in sensitivity and specificity affect the outcome of clinical testing. To facilitate that, we've actually included some pre-populated data. That's in the menu here. We'll go through one example of strep throat. If you imagine that you have a 45-year-old patient who has a sore throat but does not have any exudate, does not have any fever, does not have any lymphadenopathy, and does not have a cough, but suppose the nurse or MA, for whatever reason, according to protocol, ends up running a strep swab on their throat, you can see that even if the swab is positive, the post-test probability is only 22%. That's not really actionable and indicates the test probably shouldn't have been done in the first place. And the reason for that is because the pretest probability is so low. Because of the low pretest probability, the test can never really provide useful information. However, if the patient had been 5 years old instead of 45 years old, because the pretest probability is higher, you'll see that the post-test probability of the test is also higher, almost 70%. So this is an actionable bit of information, is now that the test is positive, you could implement treatment. And as the child had more and more signs and symptoms of strep throat, the post-test probability gets higher and higher. But the post-test probability of a negative test actually degrades. So in this 5-year-old patient who does have exudate, does have a fever, does have lymphadenopathy, and does not have a cough, if the strep swab is negative, there is a residual 15.2% probability of disease. And so despite the negative strep swab, a throat culture might be indicated, or even prophylactic treatment. And again, perhaps the test was not necessary in the other direction and treatment could have been instituted regardless of the results of the strep swab. The other feature of the app here is these sliders that change the uncertainty level. As we all know, in studies, the pretest probability can often have a range of plus or minus 5%. So you might say that the probability is 20% plus or minus 5, and that would correlate to 15 to 25% probability. Similarly, the sensitivity might range from 82 to 86%, which would be 84% plus or minus 2. And likewise for specificity, maybe 95% plus or minus 5%. And those are reflected in these bars here. You can see that as the uncertainty increases, the uncertainty in the result also increases. And the range of answers is indicated here. So for a 23% pretest probability and a test that is 84% sensitive and 95% specific, the post-test probability of it being, if the test is positive, is 83.4%, and if the test is negative, it's 4.8%. But because of the uncertainty, the range for a positive test is actually between 57 and 100%, and for a negative test is anywhere between 2 and 9%. And that just gives you an idea that in all of these studies, there's a 95% confidence interval stated, and that affects the certainty that you might have with the test. A few additional features. you can create an account, and by doing so, you can actually create your own data and have that saved in the database, which will then be accessible in this list. It'll show up in this list here along with all the other examples, and will be accessible from any device. If you create an account, you'll also be able to subscribe for $1 a month. And if you subscribe, you get access to additional test information, including breast cancer, pulmonary embolus, DVT, UTI, endocarditis, pneumonia, and H. pylori right now. And we'll be adding more and more data to the paid data set as time goes on. In the account section, you'll also see links to the explanation of Bayes' theorem and the mathematics, and the clinical relevance information on what we use what we should be using Bayes' theorem for in clinical practice. Those are the major features available right now. If you have any questions or concerns, you can always contact us at rxbayes@gmail.com. We're also open to feature requests, and I hope you enjoy the app. Thank you very much.